So, whenever you're in elementary school, they give you several ways to write ratios. So, like if you have a ratio of 2 to 3, they do. Sometimes they'll start off, they'll just do like 2 to 3. They'll write the words, right? And then they also will use the colon, like a ratio of 2 to 3, like that. But then, what's one more way that they write ratios? Fractions, 2/3. And so, when you see rational, oops, I didn't mean to underline that in. When you see that word rational, the beginning of its ratio, it's going to be fractions, right? So a rational expression is going to be a ratio of polynomials. If you want to make a note right here, for it to technically be a rational expression, there must be a variable in the denominator. So, here's an example, x over x plus 1. You also could have an example like 6 over 2 minus x squared. That's a rational expression. What about 3x minus 5 over 4? Not a rational expression because, or it doesn't have to be a rational expression because you don't have a variable in the denominator. It would not be what we would consider a rational function like if we were going to graph it. No x's in the denominator. That could be written as 3/4 x minus 5 over 4, which is just a line. It's just going to be a line. Graph that. So today we're going to work on simplifying because there's going to be several steps that we have to do with this. I didn't put a slide in here for this, did I? No. Should have. All right, so what we're doing today is much like if I had the fraction 6/8. Okay? If I have the fraction 6/8, what could I do to it to change it, but it wouldn't change its value? I could simplify it. What would I get when I simplify that, Carson? 3/4, right? So one way I can think about that is 6 is 3 times 2, and 8 is 4 times 2, right? That might, probably you think about like dividing top and bottom by something when you do that, but this is another way you could think about it. I've got 3/4, 3 over 4 times 2 over 2. What is 2 divided by 2? It's 1. That, when you multiply something by 1, it's just itself, right? So the 2 on top and bottom could cancel, and I would just get 3/4. That's not really probably the way you did it like in elementary school, but that translates to what we're doing today, right? So reducing fractions is really what we're doing whenever we simplify rational expressions. So there are going to be several things that we have to think about. The first thing that we want to pay attention to are excluded, or sometimes you'll see the word restricted values. A restricted or an excluded value is any value that will make the denominator, or that bottom of your fraction, equal to 0. Because we can't divide by 0. If you go over here and you try to type in 10 divided by 0, Desmos is going to tell you that it's undefined. It's going to say you can't do that, right? Because if you think about what that means, like if you're doing 10 divided by 5, that means you've got 10 cookies and you're trying to split them up amongst 5 people, right? Everybody gets 2 cookies. Well, if you're trying to do 10 divided by 0, you have 10 cookies, and you have 0 people. But that can't happen because you got 10 cookies, right? Like, you can't have 0 groups of cookies. You have to have it, like, so the cookies exist, right? We can't put them in no groups at all. So it's undefined for that. So you cannot divide by 0. So, oops, that's from earlier. So I need to save that. Let me save that real quick. Yes, I'm going to save that. Hold on. Sorry, guys. If I don't save it, though, I'll lose it for... Alright. Alright, so, if you have anything that makes the denominator 0, you will have a value that you can't plug into that function. Okay, so we will be looking for restricted values. Now, the process for this is that you want to factor the numerator, if possible. Sometimes it won't factor. Factor the denominator, if possible. Sometimes it won't factor. And then you want to reduce using factors, not terms. Okay? You can only cancel factors, not terms. And down here, I didn't make these notes. I usually say that if you cancel like this, it kills a math fairy. But these notes, I think these notes came from Miss Martin, but I think she got them from somebody at North Surrey because she, so I left this in here. I've reworked it some, but I think it's a good thing to remember that when you're canceling, you cannot cancel things with plus or minus signs in between them. Those are considered terms, right? So if you see, oh, I've got an x squared on top and an x squared on bottom, but that x squared is being added to other things, you cannot cancel them. If you do, it is going to kill a kitten. Or we'll just say a math fairy. No actual kittens will be harmed. But I always say it kills a math fairy if you do this. And I've taught this long enough to know that some of y'all are going to be murdering math fairies left and right with your canceling. Kids do this wrong so often. And I will call you out if you're killing math fairies with this. So the reason this does not work, think about it with numbers instead of x's, right? Sometimes things are easier to understand with numbers instead of x's. If I had the fraction 2 plus 3 divided by 2 plus 5, right? If I had that fraction, then I would just need to add the top numbers together, which would give me 5, and I would need to add the bottom numbers together, which would give me 7. So this is equal to 5/7. This is correct. This is what you should do. But if I cancel, like this person has canceled in this equation right here, 2 plus 3 over 2 plus 5, then I would just mark those two out right there and say, oh, that is 3/5. Is that equal to 5/7? It is not. 5/7 and 3/5 are not equal to each other. This is wrong. We cannot do that. Now, what we can do is if I had, like the example I showed you a minute ago, if I have 2 times 3 over 2 times 4, that, if it's multiplied, if I have factors, things that are multiplied together, I can just cancel these, and that's equal to 3/4, right? Because if I do it the other way, 2 times 3 over 2 times 4, I will get 6/8, which can be reduced to 3/4. Those are still equivalent to each other. So the things you're canceling have to be multiplied. They have to be multiplied. So let's do some problems that'll make it more clear what we're doing here. So 1 is going to be a little bit easier of a question because it is mostly already factored for us. The thing that I want us looking for first, it says to simplify each expression and identify all excluded values. So excluded values are anything that make the bottom equal to 0. Okay? So you want to factor the top, factor the bottom. Everything's mostly factored here. Is there anything else I could factor further? Since I've asked that question, it seems like the answer should be yes. Does anybody see what I could factor further? X plus 1 won't factor, x minus 5 won't factor, x minus 5 right here won't factor. What about x squared minus 1? That still has a square in it, right? Anybody remember how to factor that one? So if I do X method on that, my last number is -1. What's my middle number? There is no middle number, so what is it? 0. What numbers could I multiply to get -1, but add or subtract to get 0? 1 and -1. So I could actually factor this a little bit further. And make it x minus 5 times x plus 1 times x minus 1. Now you want to factor completely, factor everything you can factor, and then we want to look for excluded values before we start simplifying, okay? Because if we wait to find excluded values till after we've simplified, we're going to miss some of them, okay, because they might get canceled out. So our restricted values are the numbers we cannot plug in, or excluded is the word I've used here. And they are going to be anything that gives us x in the 0 in the denominator. So if I look at that denominator, Hector, give me one number that would make that denominator 0. 1, because right here you got x minus 1, right? So if I do 1 minus 1, that gives me 0. So x equals 1 would be an excluded value. I can't plug it in. All right, Richard, give me another excluded value. Another thing that would give me 0 in that denominator. 1 came from right here because 1 minus 1 gives you 0. -1, because right here, -1 plus 1 would also give you 0. Right? So Heston, what would the last one be? A positive 5? Because 5 minus 5 would give you 0, right? This is how we were doing with the zeros. The factor is going to be the opposite sign of that excluded value here. It's the things that would give you 0 in that denominator. Okay? Now, this is just to tell us you can't plug those numbers in. Those numbers are excluded. There. Now, what we want to do is if anything is divided by itself, it just equals 1. So it cancels out, right? So I want to cancel out any factor that is on top and bottom. I can only factor things that cancel things that are multiplied together. So I'm canceling entire sets of parentheses, right? I have x plus 1 on top. I have x plus 1 on bottom. Those can cancel. I have an x minus 5 on top. I have an x minus 5 on bottom. Those can cancel. I don't have anything left on the top. What do I have to put on the top? I've got to put a 1 because it could be that, if I multiply this by 1 out front, it's still equivalent, right? It doesn't change anything. So my answer here would be 1 over x minus 1. That is our simplified version of this expression. So what's going to happen is this graph right here is going to look like 1 over x minus 1 everywhere except for these 3 excluded values. Those excluded values, if you graph this one, you're going to have like a hole in the graph there, like it won't show up on Desmos for that. But just to look at this on Desmos real quick. If I type in the original, which is x plus 1 times x minus 5 over x minus 5 times x squared minus 1. And I type in 1 over x minus 1. It looks like it is the same graph. It is basically the same graph. Almost everywhere it's the same graph. The only places it's not the same graph, if I graph the original, and I zoom in some here, at x equals 1, see if I can get there. 1 might be too hard to find. 1's going to be really hard to find. Let's look at x equals 5. That'll be the easier one to see. 5 is like right here. Oh, I just hit it. Did y'all see it turn to a circle? I'll zoom in some more. Right there. If you go to 5, it says it's undefined at that point, right? You can't really tell it from the graph. You can just see it right there. However, if I'm looking at the blue graph, at 5, I actually get a number. It's not got a hole right there. So that's and that's something we'll talk about a little bit more later. But for your purposes for checking, you can kind of tell just by graphing them both to see if they're the same. All right, now 2's not factored for us at all, so we're going to have to factor here. So if I'm factoring the top right here, I've got a negative 12 as my last number. I got a positive 1 as my middle number. So looking at that, who can tell me the numbers that I should use to factor? Okay, 3 negative 4 is almost right. 3 plus negative 4 give me a negative 1. I need a positive 1, so let's do negative 3, positive 4, right? So that top factors into x minus 3, x plus 4. Okay, then we want to do the bottom. So for the bottom, I am multiplying to get 12. I am adding to get 7. What numbers are going to work there? Four and 3, or 3 and 4. So x plus 4, x plus 3. Before we cancel, we want to do excluded values. All right, so when we're doing excluded values, we're only looking at the denominator. Jalissa, what's one of our excluded values? What would make our denominator equal to 0 there? Negative 4 is one of them. And that comes from right here, because if I plug in negative 4 plus 4, that gives me 0, right? Adela, what is the other one? Negative 3. X equals negative 3. Because if I plug in negative 3 right here, negative 3 plus 3 gives me 0, right? Okay, so you want to do excluded values before you cancel, because once you cancel, you'll lose some of them, okay? So now we are ready to cancel. If something, like this stuff is multiplied right here, if something is on top and bottom, then I can cancel it out, like that. So I will get x minus 3 over x plus 3. Those two can't cancel because they're not the same. Even though they have the same numbers, the signs and everything have to match. So this would be our answer. Okay, everybody good here? Once again, you've got to be able to factor again to be able to do this well. So that factoring just like keeps showing back up. Okay, let's go to the next one. Okay, so for the numerator, we need to factor that. That one's weird. It doesn't have a last number. If it doesn't have a last number, you're not doing X method. What do you need to do here? GCF, very good. What is the GCF for this one, Jalissa? 4x, very good. So we got 4x. We're dividing both of these by 4x so that we can factor it out. And so that is going to be just x right here. 4 divided by 4 is 1. We had 2 x's, we took 1 away, so that just gives us x. And then 8 divided by 4 is 2. The x is gone there. And that's a 4, even though it's an ugly 4. So that's our numerator. It's just a GCF. We don't do x method on it. But we will do x method on the denominator. We got to get multiply to get a positive 8, add to get a positive 6. Okay, what numbers are going to work for that? 4 and 2, positive 4, positive 2. So we've got x plus 4, x plus 2. Okay, excluded values have to come before you cancel. These are so easy to forget. And so, let's see, Sophie, what's one of the numbers that would give us 0 in the denominator? Like if we look at like x plus 4, what number would I plug in that would give me a 0 right there? What is it, Hector? Negative 2 would work over here, right? Negative 2 plus 2 would give us 0, right? And so for the 4, what would it be? Negative 4. Good. Oh, that's supposed to be a negative. I didn't write it. So we can't have negative 2 or negative 4 because it's going to give us a 0 in the denominator. So we want to do that before we start canceling. Then, Jose, what can cancel here? X plus 2's are gone. Perfect. And so nothing else cancels here. That just gives us 4x over x plus 4. Okay. Any questions there? All right, for this last one, this one's easy. Is that right? What have I done? Math Fairy is dead. Or a kitten, whichever one you prefer, whatever motivates you more to not do this. So this is totally wrong, right? That is terrible. Don't do it. A math fairy has been killed by me trying to do that, okay? It's tempting. Like right now you might be like, I would never do that. I know better than to mark things out like that. Some of you might be thinking, why not, Miss Hyatt? Why can't we do that? Well, somebody tell me, why can't we do that? It is because it's killing a kitten, but mathematically, what lets us know in this problem I can't do that? I got like a plus 6, plus 9, a minus 9. It's not multiplied by the other things, right? So it's got like over here, there's a plus on the inside of this stuff, but in between what's left, it was multiplied, right? It was being multiplied in between this and the stuff that's left. You can have a plus sign inside of the things you're canceling, but if there's plus or minuses between what you're canceling and what's left, you can't do it, okay? So don't do this. This is bad. This is terrible. We need to factor here. So if I'm X method factoring this top, and you think you won't do this, but Connor Ballard was killing math fairies the other day in calculus. He killed a couple math fairies. He has one of the highest grades in calculus. He's a very smart kid. He's still killing math fairies. You think you won't do it, but it happens to the best of us. So be careful with it. All right. We got 6, multiply to get 9, add to get 6. What numbers will work for that? 3 and 3, right? So positive 3, positive 3. So I'm going to have x plus 3 times x plus 3 in the top. In the bottom, this one's a little weird because I got a negative 9 right here. What's my middle number? It's 0 because there's nothing there. What numbers work? Negative 3, positive 3. So I've got a x plus 3, x minus 3. Do your excluded values before you cancel. So here, I'm going to have to run out of room. Let's see, Sophie, not Sophie, Sophia, what would give me a 0 right here for that x plus 3? Yeah, and really both of them are answers depending on which factor you're looking at, right? That first one would be a negative 3, and the second one would be a positive 3. So those are our excluded values. Once we've done that, we can start marking things out. Joey, what cancels here? The x plus 3. Now, only one of them can cancel, right? I've got an x plus 3 here, but I can't mark out 2 on top and just 1 on bottom, right? You got to have the same number there. So I can cancel that, and that is going to give me x plus 3 over x minus 3 there. So that'll work. Okay, I think on the back we just got one more slide that we're going to look at. Does that look right? Okay. 5 is actually an easy problem, but kids struggle with it sometimes because there's not like any factoring to do here. It's just single terms. Okay. So the numbers themselves, 60 and 80, you're just going to think about reducing those numbers. Okay. So we've got 60 and 80. What number could I divide both of those numbers by? Okay, 2 will work. 20 is the biggest number we could use. 20 is going to get you there the quickest. You could also divide them by 5 or by 10, but 20 will get us there the quickest. So if I divide this by 20 on top and divide by 20 on the bottom, 60 divided by 20 just gives me 3, and 80 divided by 20 just gives me 4. So I reduce that fraction just like you would reduce any fraction. Okay? And then what we're looking at here is I've got 4 x's on the top. That means x times x times x times x. And I've got 7 x's on the bottom. That means x times x times x times x times x times x times x. Okay, what happens? Like all of that's multiplied, right? It's all just multiplied. So if I've got an x on top and an x on bottom, then I don't have any x's left on the top, so I just have my 3. How many x's have I got left on the bottom? 3. There. So it would look like this. Now, I did forget to do my excluded values. On a problem like this, the 60 and the 80 are not going to make anything equal to 0, right? Those are whole numbers that do not equal 0. What number could I plug in the bottom of this that would give me 0? Why negative 4? If I do 80 times negative 4 to the 7th power, I get 1,310,720. Yeah, but even if I'm looking at like the 4x to the third, which I should not do it because I've already simplified it, but if I did look at it, if I put in negative 4 to the third, got negative 256. Doesn't give me 0. What number could I plug in there that would give me 0? 5. Even worse. What? 0. 0 is the problem, right? You can't plug in 0. So anytime it's like this, you don't have any plus or minus signs, all you have are x's, it's just 0. It's just going to be 0 because, like, that's the only number you could plug in that's going to give you 0 there. So x equals 0 is your excluded value. This would also be true if you have like a GCF pulled out. Remember how when we were doing those polynomials, if you pulled out a GCF, then 0 was one of your factors. It's the same here. Now that one wasn't a GCF because it didn't have a bigger expression, but it could be the same. We're going to see that on the next one here. All right, I've given you a difficult one for 6 because we got to do it. Most of these are going to factor more easily, but 6x squared minus 17x plus 5 does not factor very easily. Does it have a GCF? Just one, which doesn't do us any good, right? So we're going to have to, if we X method this one, what do I have to do on a problem like this to get that top number? I'm not going to do 5 and 17. I am going to do a negative 17 on the bottom. The middle number goes on the bottom. I got to multiply the 6 by that 5, so it's going to be 30 right there. So this is that difficult factoring, right? So I'm thinking of the numbers that I can multiply to get 30. Negative 15 and negative 2. That negative 15 times negative 2 gives you 30, positive 30. I like it. Negative 15 plus negative 2 gives you 17. So negative 15, negative 2. But is the factors, is it x minus 15, x minus 2? It is not. What's the extra step we have to do here? We get divided by 6. And when you divide by 6, you're going to have to reduce. Both of these will reduce. On the right side here, that will reduce to negative 1/3. Because you can divide top and bottom by 2. 15 over 6, how does that reduce? 5 over 2, because I could divide top and bottom by 3, right? So I got negative 5 over 3. X's go with the stuff in the bottom. So oh, I'm sorry, that's a 2, not a 3. So I'm going to have 2x minus 5 over 3x minus 1. Most of them will be easier than this, but you will run into a few where you got a factor like that. What about the bottom? I don't do X method because I don't have a last term, right? We can. 1 is the number. What can come out with it, Samara? An X can come out. So even though there's not like a number we would divide both of those by, both of them have X's. So we could pull an X out. And so if we pull an X out, we're just like taking an X away. So we got 2x minus 5. Oh, that looks, you should also notice on these, like, they're usually going to, something's usually going to cancel. So like that looks good when I see that same factor on top and bottom. Okay? I got to do excluded values. Before I simplify. So, these are not quite as easy. What numbers would be excluded number values here? It's that 2x minus 5. I'm looking for what would make it 0. What number would I plug in? That one's not like off the top of your head as easy because it's got that 2, right? But I could go over here and I could do 2x minus 5 equals 0, right? Make me a little equation. And I just got to add that 5. So 2x equals 5. What I got to do then, Hector? Divide by 2. So x equals 5 halves is one of them. There's another one. 0. Anytime you have a GCF that has an x with it, it's just 0, right? Because if I put a 0 there, then I've got 0 times this other stuff, which will give me 0. So those are my excluded values. Now that I've done those, I can cancel. In this case, Caden, what cancels? What? Yep, that 2x minus 5 is going to cancel. And so that gives me 3x minus 1 over x. All right, questions? If you can factor, you're usually good at this. If you can't factor, you're usually not good at this. So it's all hinging on that factor in there. So we're going to have a worksheet for our assignment.